Hello everyone. Welcome back to CSE Core Concepts in my series of machine learning algorithms with implementation in RStudio. In this video, I am going to demonstrate the support vector machine algorithm for in case of regression problem. In my earlier video, I have demonstrated the support vector machine implementation for a classification problem where the output is divided into two classes. But if your output is a numeric data, that is, you have some regression problem, then how can we implement it using support vector machines? So for this, for the demonstration, I am using a data set. Say, let us say the insurance data set, which we have earlier also used. So these are the parameters which will determine the insurance premium charges. That is age, gender, BMI, children, smoker, region, and the charges. Okay. So let us assume that if you remember, let us assume that earlier we have discussed it. Let's consider that BMI is the parameter. Let's consider only if you have a linear regression model, let us say, with single variable, right? So let's say BMI is impacting the charges. This can happen, right? Or if you want a multiple variables, then you can find out which variables are contributing more. That also you can do. So let us go back here, and first let us include the library files. So the library file which we will require here is hydrogof. Okay, GOF is the library file which is for which will measure the goodness of fit. Okay, the proper fitting curve for the data points. And of course we will require for plotting we will require here ggplot also, ggplot 2, and of course we will require the package for like SVM function, which package we were using for like SVM function, that is E1071. Okay, let's consider all three. We include all the library files done, and let us read our data. So it is a CSV file which we have read. So a data frame called as insurance data has been created, which contains 1338 observations of 7 variables, right? So let's see the structure of the data. So insurance data, if I want to see the structure, let us see here. Okay, so these are the variables. Age is an integer type, gender character, BMI is numeric, children integer, smoker character, region character, and charges are numeric, right? Let us consider that, assume that only BMI is contributing for the charges. So let's say if we are going to create our model, insurance model is equals to the function which we will use is SVM. We want to compute the charges against the BMI. Understood? And for the insurance data. So let us see how does it work. So the model has been created. So if you want to see the model, right? So let's see the summary of the model. Now, if you remember, we had different kernels, right? So what kernel it is using by default? We have said that, see, it is a type EPS regression. Last time when we had done the problem for classification, here it was showing it is a classification problem, right? Okay, so the kernel which it is using is the radial function, which we have not mentioned, and the number of support vectors is 1175. So let us see that how my model will work if I am using a sigmoid function. So let's say sigmoid, because since it is a continuous data, let us create it. Okay, so this is the sigmoid function, right? Epsilon value is 0.1 and 1338 support vectors are being created. Okay, so if I want to understand how good my model is doing, so let's say the predicted model, how it is doing. So let's say predict insurance model on the insurance data, how well it is predicting, right? So if I want to see insurance predictions, I can see it will give me a long values, right? So the basically what I want to know is the error, how much error it is being created. Okay, what is the actual value? What is the error between the actual value and the predicted value? So let us directly calculate the root mean square error. So it is RMSE function. So I want to know the root mean square between the predicted value and the actual value, which is in insurance data charges. Okay, so I want to see the root mean square error and RMSE. Let's see the value what it is producing. So 80,000. Sorry, yeah. So 80776.2.4 is the root mean square error. Right. Now, if I want to find out, let us see. Do one thing. See, this is a regression problem with single variable, right? So this always you can do with that function also, LM function also, that is regression with single variable. Let us do the same problem with the same function, okay, and let us find out which algorithm is giving us more error, root mean square error. So let us read the data, and this time what I am doing is I want to create a model for regression model, okay, that is using the linear regression model using single variable, right? So insurance data charges we want to calculate. So I want to calculate it against insurance data BMI. Okay. So, and the data is my insurance data. If you remember, if you don't remember, please go through my earlier video where we have discussed about the linear regression with a single variable. Okay. So you can always see the summary of your model, summary of the model which we are doing, which we have created here. So this is the summary which is giving us all the values, right? You remember which parameter, this triple star I had discussed. That means the p value is 99.9%. So it should be less than 95 is not acceptable. Okay, so I hope you remember that. So this is being created. Now let us see how good prediction it is doing for us. Right. So if I want to see the predictions, uh, let us use another function here. Insurance prediction. Let me give a name. Okay, RMSC. Okay, insurance prediction using linear model is equals to predict. Prediction will be done using this model, regression model. Okay, with the data is your insurance data, right? And you can see the predictions, insurance underscore prediction underscore linear regression model. So here you can execute them and you can see somewhere. But of course, we let us see the RMSE of linear model is equals to root mean square error, okay, of insurance underscore prediction underscore LM linear regression model against the data, which is the actual data that is in the form of charges, right? And let's see the RMSE underscore LM value, what is being computed. Okay, so here you can see the value which is being computed is 11,864.99. This is the root mean square error. Now same thing you can do using separate kernels also, that is also possible, or you can include some other parameters also. Let's say for example if you want to include age, okay, age was also one of the parameters. Okay, so you can recreate your model, that is you can do it for multiple predictions also. This is the root mean square error which you are getting. Similarly, if you are doing the same using your age, right? Linear regression model, that also you can compute. Okay, so you can see how much error it is being given. So in this way you can calculate you can perform the regression using support vectors also apart from your linear regression models. Here the kernels can also be changed as I have already discussed in support vector machines. So you can always, which are the other kernels? So radial kernel is the default one, sigmoid, polynomial and linear. So you can even use a linear kernel here and you can just find out whether the error is decreasing or not. Yes, you can see there is a drastic reduction in the error. Earlier we were getting errors like 54,000 and all, right? So you can see there is, so because it is a linear prediction model, right? The relationship is linear. So here you do not have much difference between these two RMSE, right? Here also you are getting the RMS value is using linear regression model is 11,000 and using this SVM is also nearby, right? So if you fine tune your model, you can get a near way of the models. I hope you understood this linear support vector regression model, which can be used instead of your simple linear regression models. So in my next video, I am going to discuss about the random forest classifier in RStudio. So don't forget to like, share and subscribe to CSE Core Concepts. Thank you.